Hello, and welcome to Geometry. We're doing Unit 1, Lesson 20. We're going to be talking about constructing a triangle, given its sides. And your learning target today, you should be able to say, I can construct a triangle given its side. All right? That's the learning target. We're going to give you the sides of a triangle. You're going to construct a triangle. It's that easy. But it takes practice. Let's see what it takes. Our warm-up. So, last time we talked about the definition of a circle and arcs on the circle. And remember, a circle is a collection of all the points that are equidistant from the center point of the circle, and that an arc is just a continuous portion of a circle. An arc is just part of a circle, and a circle is all the points around a particular center. All right? All right, exercise 1. In the diagram below, segment AB, right here, segment A to B, is a length of 3 inches. In other words, AB equals 3. Locate a point C. So that means we have to locate another point, to call it C, such that C is 2 inches from A and 1.5 inches from B. All right? All right, let's try this. I'm going to need to use one of my handy tools over here. Um, Now, my tool is going to be a little different because if I measure from here to here, I don't get 3 inches, I get 3.43 inches. So I'm going to have to measure what 3 inches is. Well, there's what 2 inches is. That's what 2 inches. Well, 1 inch is 1.1 on my ruler. All right. So 3 inches is going to be 3.33. All right. So I want to get one that's 2 inches away from a C that's 2 inches away from point A, which means something that's 2.2. 2.2, right? Something like that. This point here is going to be 2 inches, 2.2, well, maybe it's 2.8, 2.9. I'm measuring. All right, let me see what I can do with this. Let me see if I can click on that point. Nope, it's not going to let me click on that one point. Okay, well, in that case, let me try again. And so 2 point, what did we say? 2 point, oh, I already forgot. 2.38, was that what we said? No? Oh, jeez. I gotta remember, I gotta do this again. I'm measuring 2 inches is 2.28. Nope, nope, nope. 2 point, I'm gonna say 2.29. 2.29. So I need something that's 2.29 on my, I'm sorry for the conversion. I didn't print this out on paper. So that's what we're stuck with for right now. 0.29. All right, close enough. We want something that's 1.5 inches from point B. 1.5 inches on my ruler is going to be 1.7. So something that's 1.7. 1.7. So as you can see, I need something that's a little bit, this point here has to be a little bit lower. I need one that's going to be, 2.8. There we go. That's something more like it. Forget this guy right here. This one is about 2 inches in length, measured on this side ruler here, and it is about 1.5 from here. So there we go. We could then call this point C. All right. Let me see my toolbox here. Okay, I guess I'm going to have to use a different tool. Oops. Told the computer to do something I didn't want it to do. And I deleted my thing. Oh no. And I told the computer to do something else very silly, didn't I? Call it point C right there. That happened. That happened when I have. Oh, there it is. There's my. Oh, I need to change. Sorry. There. So point C is going to be this point right here. That's going to be point C, which is 2 inches from point A and 1.5 inches from point B, give or take, given the limitations of I'm not doing this on paper. I'm trying to show you this. putting a layer on top of a PDF here. Still experimenting with the technology. Bear with me. I'm trying my best. All right, now I'm going to get rid of all this. So we're done with exercise 1. If you still needed to complete exercise 1, you could pause that video, go back, pause the video, and finish it up, or use your ruler on the paper that you have. So exercise 2. Using your ruler to only draw a straight line, construct a triangle that has side lengths that are the same as the three segments shown below. Well, actually, this gets a little easier because now I don't have to convert measurement. I just have to measure this. This is 1.72. 1.72. Let me write that down. Whoops. 1.72. And let me measure this one. This one is 2.28. So this one is, oh, no, that's not what I wanted. I wanted the blue pen. 2.28. Sorry for that being messy. I am struggling with doing this on a computer. This is a challenge. This one is 2.7. 2.7. 2. I did the same mistake again. Look at me. Eventually, this will become second nature. But until then, we're stuck with what it is. Okay, so I'm going to make one side 1.72. Here I go. 1.75, 4, 70, 71, 72. There we go. Now I need another point, which is going to be 2.28. 2.28. Where is it? Right in there somewhere. 29. Oop, I had it. It was there for a second. I'm gonna have to go with close enough. I'm gonna go with 2.9 is close enough. I actually need this to be there, and I'm gonna have to go again close enough. Oh, I did hit it just right there. All right, and now I need my other one, 2.7. 2.7. So this has to be somewhere over here. 2.7. 2.7. Again, I might have to go close enough. So this point here, oh, I don't want another line. I actually want to redo this line. I guess I can't do that. So I'll just redraw it. 2.28. Okay, that gets closer. If I could delete those, I would do it. But 2.7, 2.7 is going to be here. Trying to figure out what's the perfect example. I'm going to have to bring, oh golly, how am I going to get these two together? This one will need to be over here for me to get 2.28. 2.28. There it is. That's a much better, sorry about that. That's a much better, I'm very close to where it is right now. If you can see, I'm going to freehand this now. I know that's going to be ugly. I'm going to kind of freehand this. But this triangle here, I've experimented with different lengths, is about what it's going to be. All right? That triangle there is going to have one that's, oh my gosh, I don't know what I even wrote over here that it's so messy now. It's going to be about my 3 lengths, if that makes sense. So with the ruler, you got to play around. Oftentimes what I would do is I would draw one leg, then I would take a measurement of 2.28, and then I would make a measurement, a copy of that measurement with my compass, pin it down, and I would create an arc mark. So I get all the points that are 2.28 away from that one point. And then on the other side, I take a measurement of 2.7 and lay my compass right on this point. I'd lay this compass right on this point, taking a measurement of whatever this is, and I would do an arc mark the other end. And where the two arc marks meet, that's where I know the sides of my triangle have to be. If I had a digital compass to kind of show you, I could do that. Now, this tool, the set that I'm working with, does allow me to pull a protractor on the screen, which is pretty neat. It's not as good as having an actual compass or circle tool, which they seem to have neglected to let me have. Oh, wait a minute. Perhaps Mr. Souls has not realized the true power of what he has here. Okay, well, oh no, I have not. Look at that. I do have such a tool set. Oh, do I have to use it? You want me to use it? I'm going to use it. I'm going to play around. I did not realize I had this kind of tool set here. Okay, let's do this. For real now. Now that we have a compass, we can actually play around. 1.74, all right? 1.74. Here I go. I'm reproducing it. 1.74. I won't have to be close enough here. That's really close enough for me. Okay? And here I go. I'm bringing out that compass again. Bringing out that compass. I got to bring the compass over here. Compass. Where do I put you? No, I need to move you. How do I move you? Oh, there we go. I have to put the compass there. I have to take a compass measurement. All right. There I am, taking a compass measurement. You see that? Now I bring this over here. And now I'm going to draw my circle. There's my arc mark. Isn't that great? I know you're probably not nearly excited as I am about this, but to have a compass on here for geometry lessons is so clutch. I didn't know how to work this until just now. And I see that I do have a circle tool all this time. I was complaining about I even have a triangle and a square tool, but no, this compass is awesome. Okay, we can do this again. Here we go. Put the compass down on this point. I'm going to take a measurement. I need to take a measurement of this line. There I go, taking a measurement with my compass tool. Now last time I measured from this point, so I have to bring my compass tool over here this time. And now I'm going to measure my compass. There it is. Do you see it? Do you see the point where I need to draw these lines? From here to here is going to be, did you see that? That was 2.27, just like what we measured before. And then from here to here is going to be, oh, that's going to be 2.69. Was that the measurements we got before? Oh, yeah, 2.69 and 2.28, right? 2.27. So you see that this triangle we've built right here with our compass uses the exact same side lengths of what we have here. This is awesome. I'm excited. I hope you're excited. If you have a compass, use it now. Do the same thing on your page. All right? I'm going to delete all this, so if you need this, pause the video here. All right. Sorry to get my tools in your way. All right, let me move that around there so I can play with that later. Woo! All right. Exercise 3. Oh, exercise 3. I need to undo my tool to get over here. Use tracing paper. Now, maybe you have tracing paper, maybe you don't. Tracing paper to compare your triangle with the student sitting next to you. How do they compare? Are they identical except for their locations on the page? Well, I deleted everything. I'm not going to recreate it. But, use your tracing paper. See if the triangle that everyone else created was the same as yours. If you're not with anyone, I'm going to spoil the surprise. Guess what? If you created a triangle with those particular 3 side lengths right here, you will create a triangle of exactly the same size. If all 3 sides of a triangle are the same, that triangle is going to be identical to another triangle where all 3 sides are the same. All 3 angle measures are going to be the same. it's going to be completely congruent. Completely congruent. The triangles with the exact same side measures will be completely congruent. All right? Sorry to spoil that for you. So we say in geometry that two figures are congruent if they have the same size and shapes. Remember that. Congruent means same size, same shape. You know, we tested with hopefully if we have the tracing paper in class, you can use the tracing paper to test this theory out. It's absolutely true. You can test it out over and over again with all sorts of triangles. If two triangles have exactly the same side lengths, they will have exactly the same angles. They will be completely congruent. All right, let's go. We'll move on to the exploration. So in geometry, we call this the side theorem. Side theorem. Triple S. Theorem for triangle congruence. If three sides of one triangle are the same length as the three sides of another triangle, these two triangles are congruent automatically. We'd say it just like what we have here. Triangle ABC is congruent. Is congruent. I don't know if you can see that. Let me zoom in. Oh, I'm just showing off my tools now, to be honest. I'm just showing off my tools. Triangle ABC is congruent with triangle DEF. Do we see that? Oh, look at that. High technology we're playing with here. High technology, folks. We do not use the equal sign when we mean congruence because we reserve equality for numerical quantities. So when we're talking about geometric shapes, we're going to use that congruent sign. That's the equal sign with a little squiggly on top. Congruence. All right. Exercise 4. Triangle ABC is shown below. Using your ruler only as a straight edge, don't do any measurements here, construct DEF such that DEF is congruent to ABC. In symbolism, triangle DEF is congruent to triangle ABC. So we needed to construct the exact same triangle over here. So here's how we're going to do it. I'm going to take a measurement. I'm going to take a measurement from A to C to start with. A to C. The measurement I'm taking is 1.76. 1.76. I'm going to do that over here. 1.76. I'm going to try to get as close as I can. Here we go. Boom. 1.76. Got it? Now I take another measurement from B to C. So I'm taking a measurement here from B to C. And I've got 3.06. 3.06. 3.06. 3.06. And there it is almost. I'm so close. Why won't it? I'm going to have to go close enough. 3.0. Oh, I had 6. There we go. 3.06 right there, precisely. All right, let's do it again. From A to B, we've got, I'd say, 2.11. 2.11. 2.11. All right. Now notice how mine aren't connected precisely. That's because my angle measures must be off. This is the problem with just using your ruler as an angle measure. See, now I'd have to then adjust this point to go in, and that's going to be hard to do. I'm going to undo that little line I just made. I'm going to undo the other line I just made. And again, this is where the compass is our friend. This is where the compass is our friend. I'm going to take a measurement. I'm going to take a measurement starting right there, opening up my compass. Come on, compass, open up. Put that point right there, perfect. Open up my measurement until I get to B. There. I'm measuring to B. Actually, that's not quite on there, is there, right? Let's get more precise. We can do better. We can do better even with this technology. There we go. I like it. Now I go over here, put that same point right there, and now I got to draw this arc. All right, I'm drawing this arc. Now I'm going to go over to C, put the point right there. I need to take another compass measurement. Is my compass even big enough? Whoop. Is my compass even big enough? No, I don't want to draw. I want a measurement from C to B. From C to B, right there. Right there is where I have from C to B. So now I take my compass and I move it over here, and now I want to draw. Where are these two arcs going to meet? They're going to meet right there. Do you see that? These arc marks meet right there. Pardon me, I'm going to cough. And so now I draw my straight line. Now I want to draw my straight lines. Use orange from here to there, which is 1.14, which is really close to what we measured before, and 2.14. Let's just confirm this. 2.14, just like we measured, and 3.08. I think that was pretty close to what we had over here, right? You have to allow some tolerances here, but we've done it. We've created a triangle, all right, such that this is important. If this is A and that's B and that's C, and I want to say these two are congruent to each other, then what I have to do is I have to go the same order. If this A, B, C, I have to make D, F in the same order. So this is D, this is point D, this is point E, and this is important. You can lose points on a Regents question for not doing it this way. Oh, it doesn't like what I'm doing. Why don't you like what I'm doing? What's wrong with what I'm doing? There we go. D, E, D, E, F. All right. Sorry for the technology issues. We're getting better, right? The compass is a big improvement. I like that quite a lot. We have constructed DEF such that DEF is completely congruent to ABC, and we did that with our compass. The compass is such an important tool because it creates circles, and using circles, we can create other things. That's why we learned about circles and arcs in the past, so that we can start creating congruent triangles. And honestly, congruent triangles, that's what we'll be playing with for a long time, a long time in geometry. Congruent triangles, making sure triangles are congruent. All right, let me get rid of everything I've got here. Moving on to the next exercise. And when I press the button again, all that stuff I drew will come back. I'll delete it, deleting all that junk. All right. Moving on, next exercise. A right triangle, MNP, MNP. Construct QRS such that QRS, triangle QRS will be congruent to triangle MNP. All right. All right. We need to break out that compass again. We need to take out that ruler again. Here I go. Here's my ruler. I'm going to measure this one first. M to N. M to N is 270. I can place this one, actually, let me call it 267. I can place this one anywhere. I can place it, like this. It doesn't have to be, as long as it's the same length, everything else will be taken care of. Even though this is not parallel, it's not quite, I'm tilting this triangle around to show you that it can be done. That I don't need to make everything exactly precise. So here's my compass tool again. I'm going to open that up a bit. I need to now place this point on N, and I need to measure to point P. I need to measure to point P. Whoop. So that's what I'm going to do to measure to point P. You see how I have that edge of that circle there on point P? Well, then I'm going to move my compass over, and now I'm going to draw that arc mark. Once I get that on there good, might change the color. There's my arc. All right, now I move my compass over to M, and now I want to take a measurement from M to P, from M to P. So do you see how I got it right there? It's on the circle, right? So now I'm going to move my compass over to my other edge, and I want to draw this arc. I want to draw that arc. All right, I've got it, folks. I've got it. All I have to do at this point is connect this point to that point, and then this point to this point. And now this triangle here, which I will call, let's see, this one is MNP. I need to call this one, let me grab my pen, let me choose a color that I haven't used yet. All right, so if this is MNP, and I say these two are congruent, then this has to be Q, R, and S. All right, QRS. We have constructed QRS such that triangle QRS is congruent to triangle MNP. Boom. How do you feel about this? In that lower right hand corner, give me that smiley face reflection of how you're feeling. Smiley face for this is easy. I like this. Frowny face for I'm confused, I'm lost, I need help. And something in between says like I'm feeling slightly uneasy, but I think I got this. I just need more practice and more work at it. That's where we mostly want to be. Exercise 6. This is an example of some triangles are just not possible. Why are some triangles just not possible? Well, let me show you. I'm going to delete all that stuff I just did. Let's take a measurement of the triangle here. This side here. This is 1.16. Let me add 1.16 to this side here. 1.16. There it is. I added this to this. What do you notice about these? Think about this. Can I possibly make a triangle out of this side length, and this long side length? Why can't I do that? Pause the video. Think about this. Why can't I possibly make such a triangle? Well, I hope you're unpausing the video now and you're thinking, there's no way. These two sides don't even reach. 1.16 won't even reach over there, right? There isn't a possible way. If this one is 1.67 and I try to make 1.67 reach over here, it's okay. Maybe I can get it over there. I'm never going to get another side length of 1.15. I'm never going to get 1.15 to reach there. It's never quite going to get there, right? This side length is too long. These three side lengths cannot make a triangle. So write that down on your page there somewhere, that you can't possibly use these three side lengths, since these three side lengths, the shorter two, do not even add up to the length of the second. So if you need me to do that, again, told the computer to do something I didn't want it to do. Still learning the technology. These three segments cannot possibly add up to, or cannot possibly be used to construct a triangle because the shorter two sides are not long enough to bridge the length of the longest side. All right. So yeah, the two shorter segments here are just not long enough to make the gap of the longest segment. Just not long enough. Pause the video here if you need more time. Using the ruler below, construct a triangle that has a side length of 3, 4, and 5. 3, 4, 5 triangle. We're going to see these triangles a lot. What type of triangle does it appear to be? You tell me if it has a special kind of angle measure in that triangle. I'm going to have you do this. I want you to sit and try this. Use your compass. Give this one a shot. We've done a few of those. I think you can do this. Give this one a shot. Pause the video here, and then when you're done, unpause it, and we'll move on. All right, well, you've unpaused the video, hopefully, and you've completed this piece of the exploration. Now let's do a check for understanding. All right, what we have here is an obtuse triangle. An obtuse triangle. What's that mean? It means I have an angle measure here in my triangle, which is greater than 90. I have an obtuse angle in my obtuse triangle. So an obtuse triangle is one that contains one angle larger than 90. And we see here we have the angle measure of 110. The triangle shown below is an obtuse because the measure of angle G here is 110 degrees. Construct triangle MNP such that triangle MNP is congruent to triangle FGH. Measure angle N. Verify that it is in fact 110 degrees. Leave all your construction marks. So you'll need to take a measure of, like, say, G to F. You could start with any other side, but I would start with G to F. Take an angle, take a measure of the length of that with your compass. Put your compass down here, take that measure. All right, then use a straight edge to connect those 2 points of that measure. Then use your compass, take a measure from G to H, and then you'll put that on your, let's see, you'll put that on your N over here, and then you'll create an arc mark. Create an arc mark with your compass of the measure of G to H over here, and then you'll put your compass on F. You'll measure out to H, a little bit wider. You'll then put the sharp point of your compass on M over here of your triangle, and you'll make a compass arc mark like there, and then somewhere these 2 arc marks will combine or can intersect, and that will be the 3rd point of your triangle. You'll use a straight edge to connect all those 3 points, and then you'll use your protractor to make sure that this angle measure you've got over here will be 110 degrees. Pause the video here, get to work. Okay, you've unpaused because you finished. And again, for understanding, we're moving towards independence on these. I want you to give these a shot. We need to take some risks. We need to stretch ourselves. I know that's scary. You can do it. All right, number 5. It says, it is known that triangle ABC is congruent to DEF. Okay? ABC is congruent to DEF. If AB is 5, okay, I'm just going to sketch this out. I don't think I need to have precision here. I'm going to draw triangle ABC as just a nice little sketch here. All right, here I go. I always find it handy to just always do sketches. There's A, there's B, there's C. And I also have a triangle called DEF. I know that's an awful triangle, snicker if you will. It's just a sketch. And honestly, I'd rather do this on paper. All right, A, B, C, D, E, F. All right, AB is 5, and this is why I recommend doing the diagram, because it's hard to keep all this straight in your head without a diagram. That's 10. AC is 8, and then DF is 2x minus 6. I know that's terrible, but the best I can do. All right, then solve for the value of x. How do I solve for the value of x? Well, I'm told that these are congruent. These 2 triangles are congruent. That means their side lengths are the same. If this is 5, then this is 5. If this is 10, then this is 10. If this is 8, well, then that's 8. Well, you can solve this, right? 2x minus 6 equals 8. You can find x there. That should be an easy one. We solve for the value, and it would be helpful to draw, and it says in the instructions, it would be helpful to draw 2 congruent triangles and carefully label 3 vertices of each. Yes, it is very useful to do exactly that. All right, pause the video here if you need more time to work on this. Oh, I'm making it go away. Give me that reflection when you're done. It's always important to reflect on our learning. Tell me what's working. Tell me what needs to be improved. And it can be with me, what I need to improve, what I'm doing right. And also, I'm curious to how you reflect on your own learning, on your own preparation. Are you prepared for class? Are you doing what you need to do to be successful here? And if you are, tell me the things you're doing to be successful in this class. Reflection. It's your chance to complain and also celebrate, right? You can celebrate what's going right, and you can complain about what's not. And then I read all those every day, and I make some instructional decisions based on the reflections I see. Sometimes I'm told that I talk too fast. It happens. I do talk too fast. You're right. Then I need to be conscious to slow it down a bit when I get that kind of feedback. Here's the class credo. Here's the three visions. Here's our vocabulary. And here's our independent learning practice, or otherwise known as homework, except we often get this done in class. So, construct triangle WXY such that it's congruent to the isosceles triangle JKL. Now, isosceles triangle is a special kind of triangle where two sides are the same. I can make two marks on my diagram to say this side is congruent to that side because this is an isosceles triangle. And when I know the two sides are congruent, I also happen to know that the two angle measures are congruent. So I can create little arc marks here to let me know these two angle measures are also congruent. They want me to construct another triangle that is exactly the same, it's perfectly congruent to JKL. So I take a measurement here, I get 153. So I'm going to take a measurement here until I get 153. And you can do that with a ruler, you can do that with a compass. I did the first one with a ruler because that's easier for me, but the other marks I'm going to want to do with the compass because that just makes my life easier, honestly. Using the compass is not about making life hard, it's about making life easier. If I use the ruler, I don't know exactly where to put the angle of my point. So then I'm kind of like guesstimating, and I've got to do a lot more work. Whereas if I use this method and create these arcs, taking a measure of JL, I took a measure of JL, right? I took a measure of JL, and now I created that arc over here. Now I'm going to move my compass to KL. Here I go, moving my compass to KL, taking that measurement, bringing it down to the other point of my line segment, and now I need another arc. Oh shoot, I goofed up the measurement. Gotta go back, goofed up. Where's the measurement? There it is, there it is. L is now right on my circle. That's good. This time I won't touch this piece here. I will only touch the pencil to create the arc, and then I've got it. I then only need to connect this with that, and this with that. What do you think? Looking pretty tight there, huh? Again, this one here is going to be equivalent. Oop, that's the same as that. And that angle is that angle because it's an isosceles triangle. You could use your protractor and measure all three of these angles, and you would know that all the angle measures are the same. If you need more time on this, you press pause right now. I'm going to delete all this and move on. Oop, nope, go away. Okay, some reasoning. Bring on our geometry brains. Two triangles shown below have the same angles, and hence they have the same shape. But they want us to use tracing paper to experiment with layering the angles on top of each other. You know, I don't know if I can do this. But I'm going to give it a shot. Can my triangle tool, I have a triangle tool here apparently. Can I use my triangle tool to create something that looks like tracing paper? All right, so I want to move this one over here, and I want to move this point over here, and I want to move this point over here. So I'm pretty darn close to having all the angles correct here. But the downside is of this tracing tool is I don't have a nice way to rotate it. I wish I had a way to rotate it. That's not going to be ideal for what I want to show on the tracing paper. What I'm trying to show you here, let me just go to a line. From H to G is 1.68. But from J to I is only 1.38. All right, let's take another measurement just to be sure. Take the hypotenuse of this triangle. From F to G, I'm getting a measurement of 1.93. From I to K, I get 1.54. Are these triangles congruent? Hopefully you're saying, no, those are not congruent, Mr. Solt. They have different side lengths. Yes, they have different side lengths. And so, no, they're not congruent. Yet, they have all the same angles. And the reason is I can create two triangles that have all the same angles. They could have all the same angles, but they could also be a very different size. I could create a triangle which is inside this one. Let me kind of show you that maybe more visually. I'm just going to eyeball this, but that's pretty darn close right there, right? That's not perfect, I understand. But it's pretty darn close. Close I'm going to be able to get it, I think. This blue triangle here is pretty darn close to having all the same angle measures of my bigger triangle. And yet, obviously, it's smaller. So we have to remember this about triangles, that knowing all three angles does not tell us that the triangles are congruent. It can tell us that the triangles are similar, but they're not congruent. To know that the triangles are congruent, we need all three sides, or we need like angle, side, angle, or side, angle, side, or angle, angle, side, or something like that. Um, angle, angle, angle is not going to be good enough for us to know whether two triangles are congruent. We're going to get into more of those theorems as we progress in geometry, and you're going to learn lots more great stuff. But that's all I have for you today. I'm wishing you a good day. Remember, you matter.